Consider the density curve below. And this density curve doesn't look like the ones we typically see that are a little bit curvier, but this is a little easier for us to work with and figure out areas. And so they ask us to find the percent of the area under the density curve where x is more than 2. So what area represents when x is more than 2? So this is when x is equal to 2. So they're talking about this area right over here. And so we need to figure out the percent of the total area under the curve that this blue area actually represents. So first let's find the total area under the density curve. And the density only has area, the density curve only has area from x equals 1 to x equals 3. So it does amount to finding the area of this larger trapezoid. Let me highlight this trapezoid in red. So we want to find the area of this trapezoid right over here. And then that should be equal to 1 because all density curves have an area of 1 under the total curve. So let's first verify that. So there's a couple of ways to think about it. We could split it up into two shapes, or you could just use the formula for an area of a trapezoid. In fact, let's use the formula for an area of a trapezoid. The formula for an area of a trapezoid is you would take the average of this length. Let me do that in another color. This length and this length, and then multiply that times the base. So the average of this length and this length, let's see, this is 0.25 plus this height, 0.75, divided by 2. So that's the average of those two sides, times the base, times this right over here, which is 2. And so this is going to give us, as it should have, 0.25 plus 0.75, which is equal to 1. So the area under the entire density curve is 1, which we need to be true for this to be a density curve. Now let's think about what percentage of that area is represented in blue right over here. Well, we could do the same thing. We could say, all right, this is a trapezoid. We want to take the average of this side and multiply it times the base. So this side is 0.5 high, 0.5, plus 0.75, 0.75 high. And we're going to take the average of that, divided by 2, times the base. Well, the base going from 2 to 3 is equal to 1. So times 1. And so this is going to give us 1.25 over 2. And what is that going to be equal to? Well, that would be the same thing as 0.625. Did I do that right? Yep. Yeah, if I multiply 2 times this, I would get 1.25. So the percent of the area under the density curve where x is more than 2, this is the decimal expression of it. But if we wanted to write it as a percent, it would be 62.5%. Let's do another example. Consider the density curve below. All right, we have another one of these somewhat angular density curves. Find the percent of the area under the density curve where x is more than 3. So we're talking about, see, this is where x is equal to 3. X is more than 3. We're talking about this entire area right over here. Well, this is actually somewhat straightforward, because if we're saying the area where x is more than 3, that's the entire area under the density curve. And the entire area under any density curve needs to be equal to 1. Or you could say find the percent of the area under the density curve. Well, the whole density curve is where x is more than 3. So 100%. We don't even have to go through the trouble of trying to directly calculate the area.